Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. If you step on inside, we are looking at Big Ideas Math Integrated Math 2, Chapter 4 Test, and Cumulative Assessment. That's right, kids. If you want to check out the description section down below, you can find the PDF of those two separate portions. I'll be going sequentially, one and then the other, straight up, so if you want to find both, go ahead. You can also find... I don't know if we have graphs yet. There is a section where we solve by graphing, so we'll see. It might show up somewhere. So if there is, I'll attach graph paper, and I'll put up timestamps for the problem sets for you guys. And you can find this in the playlist with everything else that I've had so far recorded out of chapters 1 through 4 at this stage in filming. So if you want to check that out, go ahead. This will probably go relatively quickly when it comes to... Well, actually, no, I take that back. They're probably going to ask, and I'll probably figure out soon enough, with solving quadratic equations here, they had sections where you solved by graphing. They solved using square roots and completing the squared and quadratic formula. But then you hit later sections where they say solve using any method. I think even in the quadratic formula section, they talk about solving using any method. And they especially do when we hit complex numbers. You can probably even solve by factoring in some of the cases, which is something from chapter 2. So I believe if I hit any of those, I will solve using any method conceivable. So we'll see how fast it goes, but within a method, I'll probably be going over my, generally quickly, because we've seen it now before. If you need to find more things out of chapter 4 that I've done before, again, check out the playlist in the description section, and you'll find those specific sections themselves. So let's go ahead and take a look at what we are dealing with here today. Let's start with numbers 1 through 6. Solve the equation using any method. Explain your method of choice. So it sounds like we're not even getting hamstrung into any specific method at any time, so we get to choose here and now. X squared plus 121 equals, whoa, that is not registering. Let me try that again. X squared plus 121 equals 0. All right, that actually worked out that time. There are two methods I would consider here. There's really only one I would ever really want to do, and that's solve using square roots. I put this letter S. Let's try that again. This letter S. I'm referring to solving using square roots. Something's not registering on my hits here. I can subtract 121 from both sides, take the square root of both sides, and immediately we are diving into imaginary solutions. So within this test thing, this isn't like out of section 4.3 or whatever. No, this is, boom, this is like 4.7 right now. X equals plus or minus 11i. I being imaginary number sets multiplied by the 11, which is square root of 121, plus or minus meaning the two different solutions you can have in this scenario. And that's them, plus or minus 11i. Now, you could also solve using, say, quadratic formula, where your A value would be 1, B is 0, it's not here, and C is 121. I begin solving by using the discriminant in these portions, so I begin with my B squared minus 4AC. B squared minus 4AC, which becomes 0 minus 484, which is negative 484. Now, this is also a perfect square. X equals... 0, negative b, plus or minus the square root of negative 484 all over 2a, 2 times 1. So we're looking at plus or minus. Now, 484 square root is 22. So this is plus or minus 22i all over 2, which means we're looking at plus or minus 11i. It should be the same answer, obviously, and we do get the same answer. A little bit more work done there, significantly more to me. Bigger numbers, you had to do a square root within still, and that's why I would have preferred square roots. All right, there's number 1. Let's look at number 2. X squared minus 6x equals negative 58. Now, with the way that the problem's presented, I have an immediate preference. Remember, you can solve any problem by completing the square or quadratic formula. So you might be wondering why I didn't solve this one, number 1, by completing the square. Because we already have a perfect square that's isolated. So there's no reason to do that there. You just get back to where you are with square roots. Remember, square roots are the second half of solving with completing the square. And I can't solve this using square roots until I get a factored perfect square of some sort. Or squared binomial, I should say. Anyway, Completing the square comes to mind with the way that it's set up. I got a 1x squared. I got an even linear coefficient. And I already have this constant on the other side of the equation. So I'm going to begin with that and then lean in to see if this would have been factorable to begin with. It looks like it's not going to be, not even close. Divide -6 by 2, you get -3. Square -3, you get +9. 9 is what's going to be added to both sides. And when I said it's not going to be close, I mean we're not getting any real solutions out. You can't solve by factoring if you don't have real solutions. This factors to x minus 3 quantity squared, and this is -49. Now we take the square root of both sides, right? This is almost like solve using the square root once we're there. And now we have x minus 3 equals plus or minus 7i. Add 3 to both sides, we get x equals 3 plus or minus 7i. So there's my preferred go-to for this problem. Alternatively, we have the quadratic formula. Now, in order to do the quadratic formula for this problem, you'd have to add 58 over, which is something I would have looked to do if I were to also solve by factoring. Solving by factoring means use zero product property, stuff we talked about in chapter 2, but this isn't factorable. So I started completing the square first, saw that it wasn't, and we'll do this for quadratic formula still. I'm going to work out that discriminant of b squared minus 4ac. Once again, another reminder that this is going to be no real solutions, as we will get a very large negative number. 4 times 58 is 232. And we subtract those, you get negative 190. What did I write? 232. And you get negative 196. 196 is also a perfect square of 14. So this will be x equals, I'm going to do this one a little bit faster this time, negative b, opposite of negative 6 is 6, plus or minus the square root of root 196. That is 14i. 14i. All over 2a, 2 times 1. So you can see that I work a little bit faster than maybe the average person would with... I skip some steps. And I hope you don't mind that. I'm just trying to show that you get the same answer. Really, I'd solve using completing the square. It says explain your choice of method, by the way. Hopefully all my verbal stuff is working it quite well, and it's really the first one that you see me do is probably the way that you'd want to... that I'm choosing. The first one that I do is really the one that I'm choosing. Number 3, negative 2x squared plus 3x plus 7 equals 0. No matter which method I choose here, I am going to change the signs. I want my leading term positive, whether it's completing the square or checking to see if this is factorable. I'm trying to see if in my head whether it's factorable. I don't believe it is. I'm trying it out. It's not working. It's not working. If this was a 5, then it could work, but it's not. Now, completing the square is possible. It's not one that I would go to, and I don't mind showing you the completing the square bit, but I'm going to emphasize quadratic formula on this one. This time I actually do want to go to this one. Discriminant, maybe I'll show completing the square to show why I wouldn't do it, if that makes sense. Discriminant, we have b squared minus 4ac. I should close Discord. I see things popping up in the corner of my screen. You don't have to know that. Which is 9 plus 8 times 56, which is 65. This 65, remember when we saw negative discriminants here? Negative discriminants means no real solutions, only imaginary, which means non-factorable. This thing did have a saving grace of being perfect squares, but perfect imaginary squares, right? This one's not a perfect square, which is another way of also saying it's still not factorable. 65 also cannot simplify by having, it has no perfect squares inside of it, so when we write our final answer, that will be perfect. It'll just be root 65. So x equals, as long as we're not rounding, no rounding here. X equals negative b, I'm using this equation, so positive 3 plus or minus root 65 all over 2a, 2 times 2 is 4. These will be the two final answers, 3 plus root 65 over 4 and 3 minus root 65 over 4. So for all intents and purposes, guys, quadratic formula was actually quite quick and definitely my go-to. I use quadratic formula as a last resort, meaning if there's something else that isn't more usable. This was really quick. It actually worked out. Let's look at completing the square and show you why I won't be doing completing the square for problems like this in the future. Number 1, I talked about emphasizing a 1x squared. I would have to factor that you could divide by 2. I like to factor it. I would have to factor this 2 out of these two terms right here. Now, notice I didn't mention the 7. I'm going to keep that 7 on the other side of the equation. I'm going to do this like down here because I need some space. I'm going to complete the square inside here, and I'm going to add this 7 over to this side. And I'm going to add the same thing on this side. It's also got to be multiplied by 2, because 2 multiplies by whatever I add inside here. I divide negative 3 halves by 2, which is taking half of it. That's negative 3/4. And I square that and get 9/16. And this also would be 2 times 9/16 right there. This factors down to x minus 3/4 squared. It is that number that you divide by 2 that appears in there, which is kind of cool to work out. And then I got to do 7 plus this. 2 times 9/16 is 9/8, like that. So 7 is also 56/8. 56/8 plus 9/8 is 65/8. Hey, at least we've seen that 65 before. When I divide this 2 over now, which is part of what would have happened if you divided by 2 from both sides to begin with, which is why some people do that. I just don't favor that appearance. When I divide by both sides by 2 here, remember you're multiplying the bottom by 2, so it's 65/16 like that. And then I take the square root of both sides, like so. So this is x minus 3/4 here. Over here you get the plus or minus root 65 over root 16. Now root 16 is 4. You add 3/4 to both sides, you get 3/4 plus or minus root 65 over 4. With a common denominator, we'd like to write it as such, so 3 plus or minus root 65 all over 4. I'm sure there's some in-between steps that I could have skipped, but since I don't teach this part naturally very often, I'm really showing you why completing the square is not the way you'd probably be looking to do this. Quadratic formula has it beat. So I don't like using completing the square if I don't have a 1x squared here, even if I got to force it out. It's fine. I might show that 1 every so often if we run into another one like that. And if this isn't an even number, that I can be dividing by 2, especially after factorization. So there we go. All right, let's go to number 4. Now let's just find whatever things are working out here. Number 4. X squared, this looks factorable. X squared minus 7x plus 12 equals 0. All right, first I'm going to lend my hand to factoring. Yes, indeed. Solve by factoring. It's already set equal to 0. Two numbers that multiply to 12 and add to negative 7 are negative 4 and negative 3. Using zero product property, you get x equals 4 and x equals 3. My favorite go-to there. Once again, completing the square. I'm not going to use it as long as that 7's not an even number, so I'm going to forget that one. My only other version here I'm going to go for is quadratic formula. My discriminant is b squared minus 4ac. Like so. And that'll be 49 minus 48, which is 1. 1 being a perfect square, meaning this will also be factorable. Clearly it was. X equals negative b, opposite of negative 7 is 7, plus or minus square root of 1, which is 1, all over 2a. 2 times 1 is 2. I like using this quadratic formula version to show you and emphasize the fact that there are 2 solutions and we actually got to simplify them. We have 7 plus 1 over 2 and 7 minus 1 over 2. These ones actually, combine them. 7 plus 1 is 8 and 8 over 2 is 4. That's an answer. 7 minus 1 is 6 and 6 over 2 is 3. So we do get 4 and 3, a lot longer than the factoring, especially if you know how to factor that. So factoring is my go-to. All right, number 5. 5x squared plus x plus 4 equals 0. If this is not factorable, which it doesn't look like it is, quadratic formula will be my only go-to for this problem. 5x squared plus x plus 4 equals 0. Quadratic formula. Let's go. Let's go. B squared minus 4ac, oh, not even real solutions, equals 1 minus 80, which is negative 79, neither real nor even like rational, not a perfect square. So I'm going to pretty much have the answer right here, which is nice. X equals negative b, negative 1, plus or minus square root of negative 79 is I root 79. 79, I believe, is a prime number, has no perfect squares. Over 2a, 2 times 5 is 10. That should be the final. That's it and that's all. I am done. Number 6. Any questions? Number 6. We have a lot of methods we could end up using here. I'm going to be using 3 of them. Notice we're not actually solving by graphing in these ones, guys. When it says use a method, I don't defer to graphing unless they force it on me or the graph is already there. I want you to know that. Unless it's solving a system, that I might. All right, first method I'm going to go for is square roots. Solve using square roots. This already has a perfect square right there, right? I have 4x plus 3 quantity squared equals 16. I take the square root. Let me do that again. I want to put that in black. I take the square root of both sides. And now I'll have 4x plus 3 equals positive 4 or negative 4, plus or minus 4. We will add 3 to both sides. And we'll divide both sides by 4. Now keep in mind, don't leave your answer like this, and definitely don't cancel or divide these 4s out. 3 must add and subtract with these before we finish. 3 plus 4 is 7. So we'll get 7/4. We'll leave the answer like that. 3 minus 4 is negative 1. And so we get an answer of negative 1/4. Like so. That might have seemed like a lot of work. I'm not going to say I promise you it's the fastest, but considering I have to do this stuff at the end anyway, I'm guessing it probably is. I have 2 other methods I can go by. They both require you to expand this thing out. 4x plus 3 quantity squared expands to 16x squared plus 24x plus 9. This also requires you to subtract the 16 over set this equal to 0. 7. Okay. Excuse me. So my 2 other methods are solving by factoring, which I'm going to go with next, and quadratic formula. Now there are 2 reasons I'm not going to use completing the square. Reason number 1 is, as I've stated before, if I have to factor this 16 out and I can't get it down to this even linear, this can't be an even linear coefficient, it's not even going to be an integer, then I don't want to use it. Number 2 is I would get right back to here. Remember that solving using square roots is the second part of solving by completing the square. I do have a linear term, however, it would get me right back to here. So there's no reason to. We would get to where we are. All right. I know this is factorable because I know this had rational solutions. I don't know what the factorization is yet. I'm about to do that with you. So let's find out together. I have no idea what this is. I do know I'm not going to choose 16 and 1. I will try either 8 and 2 or 4 and 4, for which I have no idea which one it is. I want to give a shot at 4 and 4 first, and if it's wrong, I'll go for the other. 7, thankfully, is prime numbers. 7 and 1. I can try plus 7 minus 1. So we can work off that. Negative 4 plus 28 is 24. There it is. Okay, there's the factorization. Actually, I should have known it was this because the answers. I didn't even think about that, but that's okay. So this factors into there. 4x plus 7 equals 0. Subtract 7 from both sides. Divide both sides by 4. And I get negative 7/4. Did I do something wrong? Because here I got positive 7/4. Let me look at this. Plus 3. Oh, I had to subtract 3 over. I apologize. Subtract 3. Subtract 3. This is negative 3. This is negative 3. So let's do that again. This is negative 7/4, and this is positive 1/4. It's a good thing that we looked at a different version, different method. I probably said subtract 3 as well, and I probably just didn't do it. Okay, so I got the first answer wrong because I didn't subtract. Sorry about that. 4x minus 1 equals 0. We add 1 to both sides, and then we divide both sides by 4. We get 1/4. Solving by factoring is not bad. It's just this seems more appropriate for where we are, especially if you get it right, unlike me. It seems more appropriate for where we are. You do have to know how to factor it, and you have to know that it's factorable. I think from the onset, if you know this number is a perfect square to begin with, then you know it is, so it's up to you. Now, quadratic formula, I'm going to work off this one as well. I might have to whip out the calculator. So for the quadratic formula, I'm going to go off the discriminant being b squared minus 4ac. This equals 576 plus 448. I don't know if that's right. I'm going to say 448 for now. 576 plus 448 is 1,024, which I think is a perfect square of 32. Okay, I'm going to go off that. So 1,024. So x equals, I don't know my numbers. X equals, well, I should know from these. Negative b, so negative 24, plus or minus square root of 1024. That's, I think it's 32. All over 2a. A is 16. So 2a is 32 as well. Once again, these don't cancel. You could reduce everything, but let's first kind of add some things up. So that's negative, let's do it over here. Negative 24 plus 32 over 32, which is 8 over 32, or 1/4. That's an answer that we have. And negative 24 minus 32 over 32, which is negative 56 over 32. Oh, okay. I thought we had 4/7 as an answer, not 7/4, which is negative 7/4. Okay, that does work. I was going to say, what am I doing? Okay, so those are the two answers there. Now, this doesn't look, I've had some of my students even tell me that, through examples or their tutor or whatever that they've seen from other websites and stuff, this doesn't look like the quadratic formula you're used to. Because you're used to this big guy, right? I would have written it like this. Negative 32 plus or minus the square root of 32 squared minus 4 times 6. Oh, excuse me, 24. I'm writing this wrong to begin with. Negative 24 plus or minus the square root of 24 squared minus 4 times 16 times negative 7, all divided by 2 times 16. And then you're like, yeah, this looks like quadratic. And then you keep working that down. I understand and I agree, but you get down to this. So I'm streamlining what that part is. And hopefully you've been following me along with how I've been doing that and why I've been doing that, probably more importantly. So you decide when and how you're going to do that. So that's numbers 1 through 6. I said this video might be fast. I don't really think so anymore. Average like 3 minutes a problem. But I probably average about 2 or 3 methods a problem as well. Okay, numbers 7, 8, and 9. These should go pretty quickly. There's only one way I'm really going to do these problems. Perform the operation, write the answer in standard form. Standard form is A, A plus BI, which means the real number first and the imaginary number second, if they exist in the problem. Let's kind of first rewrite this without parentheses. 2 plus 5i plus negative is a minus, plus positive is a plus. 2 minus 4 is negative 2. Those are first. 5i plus 3i is 8i. That is the answer. Negative 2 plus 8i. Number 8. This is a minus this time. 3 plus 9i minus 1 minus 7i. This time we distribute the negative into the second quantity. This is 3 plus 9i minus positive 1 minus negative 7i, so that's a plus, which becomes 2 plus 16i. Number 9. So 7 and 8 just differ from a plus versus a minus. Once you get to the second step, you're just combining like terms. Signs, you just treat the signs as they are at that point. Number 9, this is multiplication. 2 plus 4i times negative 3 minus 5i. This is FOIL distribution. 2 times negative 3 is negative 6. 2 times negative 5i is negative 10i. 4i times negative 3 is negative 12i. 4i times negative 5i is negative 20i squared. I'm going to leave the negative 6 out here while I do negative 10i minus 12i. That's negative 22i. Negative 20i squared is positive 20. I squared is negative 1. Multiply that by negative 20, you get positive 20. Negative 6 plus 20 is 14. You get 14 minus 22i. That's your standard form. And that is numbers 7, 8, and 9. Substantially faster than 1 through 6. Solve using any method on numbers 10, 11, and 12. Now, they aren't really proposing graphing to us. I might have to show them. Okay, I'm going to show graphing on number 10 because the graph seems okay. I do not want to do it on 11. 12, I don't mind graphing them for you, but the answers are probably something we have to approximate. I'm definitely not going to do 12 algebraically because of the exponential function. So on number 10, we'll kind of do both here. X squared minus 4x minus 2 and negative 4x plus 2. Now, the first method I'm actually going to use here, though, guys, is the elimination method. Using the elimination method, what I get to do is subtract the results of what's here. It gets rid of y, as long as things are lined up and you combine like terms. By lined up, I mean proper sides of the equations. Y minus y is 0. X squared doesn't combine with anything, and negative 4x minus negative 4x is negative 4x plus 4x, which is 0. Those also eliminate. Negative 2, this isn't plus 2, it's minus 2. We're subtracting. Subtracting the whole thing, minus. Negative 2 minus 2 is negative 4. So you get that. Now, if I solved this using substitution, because I didn't solve yet, this is a stage I got to. If I solved using substitution, I set these two y's equal to each other, this expression and this expression. X squared minus 4x minus 2 equals negative 4x plus 2. And then I add 4x to both sides, and I subtract 2 from both sides, and I get x squared minus 4 equals 0. We're at the same stage for both of these problems here, basically. So you kind of pick and choose which method you like more, elimination or substitution, which one you make more sense of. But it helps to get y by itself before you start either or. So if x squared minus 4 equals 0, you can either solve using square roots or by factoring. Take the square root of both sides, you get plus or minus 2. Now, we're not done here, by the way. If I solve by factoring, it's a difference of two squares, x minus 2 times x plus 2. But I'm going to leave it here, plus or minus 2. But we're not done. Solving the system requires that you find the y's that go with these x's. Basically, what x's can go into either equation to get you the same y out. And there's more than one answer. I could plug in 2 to here to get the same y. What are those y's? We'll figure it out. You can plug in negative 2. What are the y's? Now, I'm going to use the bottom equation for this. Y equals negative 4 times 2 plus 2. It's an easier equation to work off of. Negative 8 plus 2 is negative 6. So I will have an ordered pair that's 2 comma negative 6. And y equals negative 4 times negative 2 plus 2, which is 8 plus 2, which is 10. So we have an answer that's negative 2 comma 10. Now, that also means that we can find, it doesn't mean that, but we can also find these by graphing, which is what I'm going to do next. So I'm going to take this, I'm going to make a graph out of it. The same equations from above. So let's take those and solve by graphing. Graphing. Okay, with graphing, I'm going to do the bottom equation first, negative 4x plus 2. Got a y-intercept of 2 and a slope of negative 4. I go down 4, right 1, like so. We can also go up 4, left 1, like so. And we draw the line with a line tool, like so. Or with a ruler, or whatever you have that tickles your fancy. So there's one of the guys right there. Now the quadratic, I can find the vertex. I'm going to use completing the square for this. You also have negative b over 2a as an option. But x squared minus 4x plus some blank minus 2 minus that same blank. This will be 4 when you divide negative 4 by 2 and square it. This factors to x minus 2 quantity squared minus 6. So my vertex is at 2, negative 6. Now that happens to also be one of the points of intersection. So this vertex there. The stretch factor is 1, and I have a y-intercept of, I have a y-intercept of negative 2. That's also where it intersects. Okay, solving my graphing was easy. So 1, 1. Wait a minute. Oh, negative 2. I'm sorry. Not positive 2. That's not the answer. Negative 2 is one of the things. That means there's a corresponding point over here. All right. 1, 1. 2, 4 are plotted now. 3, 9. 9 up is right here. 9 up is right here. And 4, 16. And that seems to hit this guy right there. So the graph of this guy will look like that. So it hits at the vertex, and then it hits at that other point at the top. You'll know that it shouldn't be hitting a third time for a couple reasons. One, quadratics can only have 0, 1, or 2 solutions. I guess it could have infinite, but not 3. 2, a parabola sharpens up more over time while this stays at a constant rate, which means these will split apart going like that, and they'll never touch again. So those ordered pairs are 2, negative 6, and negative 2, 10. Let's see if they match what we got above. Yes, they do. 2, negative 6, and negative 2, 10. So you have options in which method to solve. Clearly, that one seemed to take longer, depending on what you're doing. But if you already have the graph, if they force it on you, then okay. Now it's number 10. Now, number 11, I'm not going to graph with, even with that y equals negative 7. I'm not a fan of using any sort of form to get this graphable, unless it's factorable, which is not. So Now, even if it was factorable, I don't think I'd go for it. Number 11, we're going to solve, let's use substitution. Y equals negative 5x squared plus x minus 1, and y equals negative 7. I don't even know, honestly, if we solve by graphing, I don't even know if these are rational solutions. But I'm going to go with the substitution method. What color? I'm going to use green. So let's go with that. Let's say it's not, s is no longer meaning square roots. Unless I'm going to solve using square roots. I don't know. Negative 5x squared plus x minus 1 equals negative 7. Set those y's equal. Find the x's to make it work. Instead of adding 7 over, I'm going to move these terms over. I'm going to make the 5x squared positive, the x negative, and add the 1 over to get negative 6. Because I want my 5 positive. Now, is this factorable? It might be. Let me try that. 5x and x. You kind of hope these ones are for the sake of you got to plug these in for y. It's no matter. It's just you kind of expect them to be, especially if they say solve using any method, and graphing was one of them. I know the last one they expect you to use a calculator, but anyway. If 6 goes here and negative 1 goes here, you get negative 5 plus 6, which is 1. I want negative 1, so I just got to switch these signs. So this is factorable. See, yeah, if I solve by graphing, I wouldn't see what this answer would be, not by a long shot. I would actually assume it's probably something different. If 5x minus 6 equals 0, you add 6 and divide by 5, and you get 6/5. By the way, and x equals negative 1 here. By the way, I'm not going to solve using other methods like quadratic formula. Go ahead and do it. You'll get these answers. This isn't square roots. This is substitution, and that's what I went for there. Now, I'm not done. I need to still find the y values for here. Oh, here they are. Y is negative 7. Right? No matter what I say, if I substitute 6/5 for x squared right here, or for x right here, I'm going to get negative 7 apparently. And if I substitute negative 1 for x here, I'll also get negative 7. That's just the idea. That's where they intersect. There are possible no real solution cases. This is obviously not among them. Otherwise, I wouldn't have gotten x values. So anyway, there's an ordered pair that's 6/5 comma negative 7. I bring that up just because we might not run into them. And then negative 1 comma negative 7. Okay. Number 11. Now, number 12, I will solve by graphing. What I'm curious about, personally, is whether graphing by hand would get you rational solutions. Now, I said I would do it, but the reason I won't is because we haven't graphed together with a vertical shift, and it might confuse the heck out of you. So, for the sake of this problem, I'm going to simply use the calculator, which means I need to whip out the calculator. So let me do that. I'm going to get my calculator program up and running. Give me 1 second. Graphing calc. There we go. Okay, so I need to graph y equals 1/2. I know what this one will look like, at least, times 4 to the x. I don't know what x is. Plus 1. And I'm going to graph y equals x squared minus 2x plus 4. The other one's, what is the other one? Quadratic. So it's only going to hit once. Exponentials take off even more so than quadratics, and this is the only place it's going to hit. It might hit. I don't think that's rational. Let's just find the point of intersection. Calc, intersect. Let's just see what they say. That's not 1,3, right? It is. Oh, it's 1. Excuse me, it's 1,3. So it does intersect at rational solutions. Go figure. I had no idea. Then again, I'd have to graph it to figure that out. So it's 1,3. Like I said, I would have loved to graph those ones like by hand. I still can. I can give you what the drawing. Let me get the graph axes here. I'll give you a drawing. I'm not going to explain it. I didn't want to draw it though if it wasn't going to hit them. So anyway, this is essentially what you saw though. So I saw a graph that looked like this. You know what? Drawing the whole quadratic, man, that's going to take a moment. So 1/2 here, and then quadruple it. Times 4 is 8. I think right there. And that's good enough for me for the exponential. So I have an exponential function that looks like this. I can kind of explain it. I'm starting at 1/2 up from the asymptote when x equals 0. And then I multiply by 4 as x increases by 1 each time, and I go 4 times farther from the asymptote as I did before. There, that's my explanation. As far as the quadratic goes, I have a vertex at 1, 3. That is that point. Vertex 1, 3, and then a stretch factor of 1. So boom, boom, boom. Ignore that 1 point. I just accidentally plotted. Boom, boom, and that's kind of all I'm going to fit. So there's the quadratic, which, yeah. So, okay, so it hits at 1, 3, just like it found there. Okay, nice. All right, let's go to number 13. Graph the system of inequalities. Not a section, I haven't done this section yet. I think I did the review with you guys before though, right? So we did see some questions with these. I didn't do this section. That was a video as of this video's recording. Graph the system of inequalities consisting of y is greater than or equal to 2x squared minus 3 and y is less than negative x squared plus x plus 4. So y is greater than or equal to 2x squared minus 3. This graph should be fine. The next one, we'll see. Y is less than negative x squared plus x plus 4. Okay. So the first one, 2x squared minus 3, I'm just going to keep scaling using these ones for now until it seems I shouldn't. Negative 0, the vertex is at 0, negative 3 for this guy. So we're going to start here. Stretch factor of 2 is over 1 up 2, over 2 up 8. Bam, bam. And I have a graph here. Now this is a greater than or equal to, which means we get a solid line. And greater than means we get to stay above the curve at any value for y, which means we get to stay inside of the parabola. So I am going to first start by sketching lightly, using a tool, this inner part of this guy right here, like so. Sorry if it looks like there's a little bit of overlap. Sometimes after doing this, it kind of changes itself. There we go. Kind of, yeah. All right. The next one, y is less than this guy. Now this guy here, I need to, I'm going to move this over a little bit. This guy here, I need to find the vertex. Now this time I'm going to use negative b over 2a. Vertex, x value is negative 1 over 2 times negative 1, which is negative 1 over negative 2, or 1/2. If we substitute 1/2 into there, we get negative 1/2 squared plus 1/2 plus 4. That's negative 1/4 plus 1/2, which is positive 1/4, plus 4 is 16/4. 1/4 plus 16/4 is 17/4. So I get a vertex at 1/2 comma 17/4. So that is, let's change it to green or some different color. That is 17/4 is 4 1/4, right? 4 plus 1/4. So 1/2 comma 4 1/4 up there. This graph goes downward. It has a y-intercept of 4 right there, which means it gets reflexed across there. Big whoop. 1 1 2 4. I guess that's kind of where that might intersect at that point there, but that doesn't matter. We just do shaded regions. 3 9. What's 9 down from that? I think there. And I think that's all I can really fit. Okay. Now this is going to have a dotted line because this does not include points on the boundary line. It's strictly less than. Whoops, I shouldn't be crossing that point right there. Oh my gosh, why did that erase all that? I beg your pardon. Oh, actually, yes, it should be crossing that. It just shouldn't meet the, we're good. We're good. Okay. Okay. Now, the shading for that guy will be what? Underneath, because it's less than, and not less than or equal to. The overlapping shaded region represents the solution set here. Ultimately, the final answer is what's inside blue and green together. And we're inside blue and green together, including the solid line that's on blue. All of that is what qualifies. So technically, it's all of this and this that's inside that all counts. This is your final solution set. I'm not going to keep this here. I'm showing you what the final solution set is for the system. It's right inside there. That's the system. Okay, that's number 13. Number 14. Write an expression involving radicals in which a conjugate can be used to simplify the expression. Then simplify the expression. Write an expression involving radicals. Okay. So I don't know if they need variables. I don't think they need variables. All right, let's do 6 plus root 7 times 6 minus root 7. So 6 plus root 7 is something that involves radicals. Its conjugate is 6 minus root 7. It's the one where a sign changes, and when you multiply these things out, you'll have no more radicals within, because square roots will cancel out in some portions and they will square in other portions. In fact, this is a difference of two squares. This is a squared minus b squared, 6 squared minus root 7 squared. Those middle terms do in fact cancel. You get 36 minus 7, which is 29. That's it. It's open-ended. I don't know if they wanted x's with them. I don't have them. And that's it. I think that's what they wanted. I don't know. I think that's what they wanted. Number 15. Sorry if that was kind of wrong. Describe the values for C for which x squared plus 4x equals C has 2 real solutions, 1 real solution, and 2 imaginary solutions, or no real solutions, right? X squared plus 4x equals C. So the way that I imagine I want to talk about this thing here, well, I have options actually. I can talk about discriminant. I could use a completing the square format. I'm going to start actually with a completing the square format. Not full solving by completing the square, but check this out. If I do x squared plus 4x plus some blank equals C plus that same blank, this blank actually is 4. Now, this thing factors into whatever, x plus 2 squared, right? But this guy is just C plus 4. Now, what I need to do is look at C plus 4 and state when I would have 2 real solutions, 1 real solution, or no real solutions. If C plus 4 is greater than 0, if it's a positive number, you'll have 2 real solutions. C is greater than -4, 2 real. 2 real, man. I subtracted 4 from both sides. That is 1 answer. If C plus 4 was 0 itself, this is where you would just have 1 real solution. So that's where C is -4. That's 1 real. And lastly, if I did C plus 4 and had a negative number less than 0, I haven't really done a problem this way, but this is set up for completing the square so much that that's kind of how I just saw it. Then C is less than -4, has 2 imaginary. That's how they called it. So no real or 2 imaginary. If C is a number less than -4, the left side of your equation will have a negative number. And that's where you got to subtract the 2 over after square roots, and you get -2 plus or minus whatever I thing it has. So that's using a completing the square method. Using a quadratic formula method. I'm trying to think what color I'm going to use. Not quadratic formula in and of itself, more so the discriminant portion. I want to first set this equal to 0 by subtracting C over, keeping in mind C is a negative number in this case. My discriminant gets me my kind of look at this. I'm doing b squared minus 4ac. In this case, C is literally -C. Now that'll equal 16 plus 4c. Okay, that's the discriminant. Now, what I'm going to do with this is the same thing as you just saw before. If 16 plus 4c is a positive number, we subtract 16 from both sides, and then we divide both sides by 4. C has to be greater than -4 for 2 solutions. I should probably turn this into green like I did the other one. Let's look at if I can do that without manipulating. I got the inside one manipulated. Let's see. Sorry about this. Hold on. Let me. Whoa! I didn't know I was allowed to do that. Forgive me. Sorry about this. Just want to get this right. I should pause my video. Okay. Let's talk about that again. If C is greater than -4, you get two solutions, two real solutions. I should just say real. If 16 plus 4C equals 0, you subtract 16 and divide by 4. That's one real. And if this is less than 0, you subtract 16 and divide by 4. Two imaginary. Too imaginary, man. So imaginary, it's real, bruh. All right. All right. Same answers as you got before. I imagine the discriminant is the way they talk about it, but the way it's set up really showed me something I could use by the completing the square discriminant bit. So I think that works out either way. All right, number 16. This would be something out of section 4.1, I believe, in and of itself. It's just simplifying radical, nothing less, nothing more. Maybe a little more difficult. We have square root of 30x to the 7th times 36 over the square root of 3. Now, I'm seeing something immediately. A couple things. I am seeing how I can interact the root 30 with the root 3. You have to remember, this is all really treated as one term. I can rewrite this whole thing as, like, say, 36 times the square root of 30 times the square root of x to the 7th, all divided by the square root of 3. I start some of the split up here, but I join these as one fraction, so you can see the division of two things which can interact. Root 30 divided by root 3, in fact, can interact. So instead of trying to rationalize this denominator, I'm actually going to divide these out. Square root of 30 divided by square root of 3 is the square root of 10. So I get 36 times the square root of 10 here. Now, square root of x to the 7th, the concept behind here is you pull out all the perfect squares you can. How many x squareds go into x to the 7th? 3 of them. You divide 7 by 2. How many 2's go into 7 is 3. So you get 3 powers of x that come out, and there's an x that remains inside. A 1 power of x. It's 3 with a remainder of 1. So the final answer here is root 10 can't simplify. It's going to be 36x cubed times the square root of 10x. Now, rationalizing a denominator is something you could have done, but I simplified things first, and so I took care of it. That'd be the final answer. Number 17. I think I have 3 more questions on the test portion. Yes. Number 17. A skier leaves an 8-foot tall ramp with an initial vertical velocity of 28 feet per second. The skier has a perfect landing. How many points does the skier earn? Oh, this is cool. Maximum height, they get 1 point per foot. Okay. The skier. Oh. 5 points per second. I like this kind. I've never seen a question of this kind of like, you get to do more like this. We've done it, sort of. We've done the dollars, but this one's a little more fun. All right. A skier leaves an 8-foot tall ramp with initial. Okay. So the bottom line is, and I've been using initial height as h0, but the book's been using s0, so I'm going to do that. Initial height is 8 feet. Initial velocity, vertical velocity is 28 feet per second, and it's positive because the skier's going upward. Acceleration due to gravity is -16, so we've seen a lot of that before. The height of the skier with respect to time is -16t squared plus 28t plus 8. Okay. Now, how many points does the skier earn? We're looking at something regarding maximum height, time in air. I don't know what perfect landing means. Oh, the skier has a perfect landing. I was like, I don't know what that means mathematically. It looks like we just get to add. The skier at least gets 25 points. Plus whatever kind of height stuff they get. All right. What I'm going to do is Let's do the maximum height portion first. I'm going to be using negative b over 2a. I got to find the time for vertex, substitute that back into here, and figure out at what time we're at. And I might use the decimal. I'm trying to do some more in my head. I'm not going to do that. Negative b over 2a, which is negative 28 over negative 32, which is negative, I don't know, I'm having trouble with that, 7/8. Oh, a positive 7/8. I don't need a calculator for that one. 7/8, which is 0.875. I will need the calculator for this next part. It takes 0.875 seconds to get the maximum height. Now, h of 0.875 is the part that I'm going to use the calculator for, and I'm just, just let me compute this, please. Negative 16, oops, I'm not even, negative 16 times 0.875 squared plus 28 times 0.875 plus 8. 20.25 feet. So here's how many feet the skier reaches at a maximum. It's less than a second into the jump. Time in the air. How long's the skier in the air? This time we get to take that same equation, negative 16t squared plus 28t plus 8, and set it equal to 0. At what time do we get a height of 0? And we're going to figure that stuff out. I'm going to change all the signs here. Actually, I'm going to divide everything by at least 2. At least 4. So 4. Negative 4. Divide everything by negative 4. I get 4t squared minus 7t plus minus 2 equals 0. And I think, thankfully for us, this is factorable. So 4t and t, we get a minus 2 and a plus 1. Negative 8t plus 1t is negative 7t. So we set these equal to 0. You get t is negative 1/4 here. We can ignore that time. It's negative. That is pre-jump. Here t equals 2. That is the time the skier's in the air for. 2 seconds. Okay. To get the answer of how many points does the skier earn, 1 point per foot in the air. So they get points, total amount. You'll get 20.25. I wanted to say more. I wanted to use units, but it's 20.25 feet times 1 point per foot, so 20.25, plus 2 seconds in the air times 5 points per second would give you 10 points, plus 25 points for the perfect landing of the skier, which is 20.25 plus 10 plus 25. I don't want to get that wrong. 55.25. Whoa. 25 points. Almost a perfect 56. Not even close to a perfect 100. Did I do that right? I think so. 55.25 points. Kind of cool problem. I mean, it's ultimately they ask some questions and you see unit conversion, but I like how they kind of work something up with it. And we had to create the equation to begin with, right? If you don't create the equation, you got nothing. Number 18, you are playing a game of horseshoes. One of your tosses is modeled in the diagram. I'm going to copy and paste this diagram. I want it bigger for you guys and for myself to be able to draw on it. It's big enough, thank you. X is the horseshoe's horizontal position in feet, and Y is the corresponding height in feet. Does the horseshoe reach a height of 8 feet, 4 feet? Explain and reason. I actually don't really need this diagram. I'm not going to erase it, but I don't actually need the diagram. Diagram's just there to be there to explain away what you're doing. Okay, does it reach 8 feet or 4 feet? All that. Why is the height based on these x distances? At some certain x distance, we can reach the maximum height. Does the maximum height's vertex ever reach 8 feet? Does it ever reach 4 feet? For the most part in these problems, it generally doesn't reach the higher one and it does reach the lower one, but you got to kind of show them. So I have negative 0.01x squared plus 0.3x plus 2 equals, we're going to test it when it equals 8. Do I dare leave these as the small numbers? Sure, that's fine. We're just working on discriminant. I got to set this equal to 0. So minus 6 when I subtract the 8 over. So your discriminant in this case is b squared, 0.3 squared, minus 4ac. I'm going to let the calculator help me out here a little bit. Basically, well, maybe I can do this. 0.09 minus, I think that's 0.24. 24 times 0.01. I think that's 0.24. So that's negative point. Basically, it's a negative number. Negative 0.15, which means does not reach 8 feet. Does not reach 8 feet. What I'm doing here, and you have different ways of solving this. If you wanted to go vertex route using negative b over 2a and plugged it in and found out your vertex, that's totally fine. I'm going the discriminant route. Maybe I can use the vertex route after. So the other version is setting the 4 point x squared plus 0.3x plus 2 equals 4. So I subtract 4 over from both sides. So it says minus 2. So your discriminant this time, b squared, 0.3 squared, minus 4ac. Oh, this gets close. 0.09. This is minus 0.08. So 0.01 is just barely positive. I mean, a discriminant's a discriminant, but basically the point is it does scratch. You have real solutions when y equals 4 when they intersect, which means it does reach 4. So it does reach 4 feet. It does reach 4 feet. Okay, so those are the two answers. Now an alternative to this is using this equation. This actually may be faster for me to go this other way because you can answer two things in one. So with this one here, you can get the vertex x value. You get negative b over 2a, which is negative 0.3 over negative 0.02, which is, I don't know why I don't know that faster, 15? I guess it's horseshoes. It's showing how many feet you get to its maximum distance. It takes 15 feet. So you substitute 15 into your equation to get the y value, and you get negative 0.01 times 15 squared. I'm trying to do this without a calculator. 0.3 times 15 plus 2, which is negative 2.25 plus 4.5, which is positive 2.25 plus 2. 2.25 plus 2 is 4.25. So your vertex is at 15, 4.25. 4.25 is greater than 4, but is less than 8, which is how it answers these two questions. It does reach 4 feet. It does not reach 8 feet. That was actually faster. And perhaps more worthwhile for you, so you can kind of see those two answers for, whoops, you don't see that. See those two answers for what they are. Okay, last question on the test portion, number 19. Almost at the hour mark here as well. The numbers of two types of bacteria after X hours are represented by the models below. We got y equals 3x squared plus 8x plus 20. That's type A. And then y equals 27x plus 60, which is type B. I don't intend on graphing these unless they force something out of me because of the intercepts here, or just the distance. When are there 400 type A bacteria? What's X? X hours. So how many hours do you have 400? This is the population, the numbers of two types. So for type A, part A is type A. I want to find out when 3x squared plus 8x plus 20 equals 400. I see quadratic formula in the wind unless it's somehow factorable. But I'm subtracting this over. These are going to be relatively large numbers. Now, I don't know many factors of 380, and there's no GCF here. I mean, I know 19 times 20. That won't get me what I want, though. Let me search my factors of this in my head. 38 times 10. I think this is factorable. Where would this go? Triple the 10, not the 38. Make the 38 positive, the 10 negative. Okay. Negative 30 plus 38 is 8. Yes. This is factorable. Okay. I'm going to ignore this one where you get x equals negative 38 over 3. No negative hours here, but x equals 10 hours is correct. Your quadratic formula is possible, but you know what? It was factorable. Thank you, problem. Part B. When are the number of type A and type B bacteria the same? This is where you can kind of use your different methods involved. Let's use substitution since we're not right above or right below these equations to subtract with elimination. Like I said, I'm not going to graph this. Hope this is factorable again. I hope that they came up with some clean numbers. 3x squared minus 19x minus 40 equals 0. I'll tell you what, if it is factorable, good on them spending some time to get some problems that would actually work out this way for something that very few people go to. A chapter test review after the other review and the last problem on it. So if these are, and coming up with these problems take a while to come up with, especially when it's two equations. I don't know if this is factorable. I'm trying in my head. This one might not be, though. But if it is, kudos to them. 5 and 8. Oh. 5 and 8. Okay. Hold on. Triple the 8. Make that negative in the 5 here. So, negative 24 plus 5 is negative 19. Yes. All right. X equals negative 5/3 will be ignored. But x equals 8. 8 hours in, the amount of bacteria will be the same for both of these. Kudos to them. Good problem writers. Part C. Especially because how obscure the numbers are. When are there more type A bacteria than type B? When are there more type B bacteria than type A? Use a graph to support your answer. I was going to use a graph to support my answer. Not that I was going to graph, right? But this is kind of nice to look at here. 3x squared plus 8x plus 20 is a parabola. I don't know exactly what the parabola looks like, but, you know, it's going to be some sort of version of something, right? Something like that. Now, the linear equation will have some form of, what was it, plus 60. This isn't drawn to scale, by the way. Not even close, so you can just take that as... Let me redo this. Now, I don't know where the vertex is, guys, right? I have no idea if it... Well, I guess the vertex can't be negative, so I'm going to assume it does something like coming from that side, bottoms out, and then shoots off that way. Obviously, it goes in this direction as well. It's a parabola. But the linear equation will have some form of 60s up here, and they cross together back there at negative 5/3, and they cross together again at 8. But this is linear. So remember, this is when x equals 8. This is when x equals 8 right there, where those two guys intersect. But being linear means a quadratic will beat it so long as that over time, so long as that quadratic is positive. You know, the linear is even positive like that too. This is just going to dominate. So between 0 and 8 hours, this thing has it beat. It's got a y-intercept of 60 versus 20. I don't know if this thing bottoms out there or not. I'm imagining it does, but it's less than. It's less than. And then at 8 hours, they're the same. So type B has more. When are there more? Type B has more bacteria when X is between 0 hours and 8 hours. We don't include the 8 because at 8 hours they're the same. So type B is green. B, green, A, blue. Type A has more bacteria when X is greater than 8 hours. I'll just write it down here. The quadratic. Okay. Also a good problem. Really good because of this stuff there. I didn't have to go to the calculator. It was factorable. Okay. And guys, that is the chapter 4 test portion review of this video. So we are going to move to 9 more questions, often involving multiple choice, but they will be cumulative assessments. So it includes things from chapter 4, maybe more so than the other chapters. And I'll try and recall what sections these things will be from 1, 2, and 3 when I see them. So let's see what we have moving forward. I got to change some pages. Okay, let's go ahead and go into this. Number 1, the graphs of 4 quadratic functions are shown. Determine whether the discriminants of the equations f of x, g of x, h of x, and j of x equals 0 are positive, negative, or 0. Okay, so for number 1, I'm going to copy and paste this graph here. We have a, do they say discriminant? Discriminants are positive when you have 2 real solutions. That means when you cross the x-axis more than once. So G, the graph of G crosses the discriminant twice, crosses the x-axis twice here and here. So G has a positive discriminant. So discriminants sorry, I have to spend time watching me write discriminants. Discriminants are positive for, I believe, just G of x equals 0. No other ones cross more than once. Discriminants are 0. Let's say negative. Discriminants are negative when you don't hit the x-axis at all. That's, say, f of x. And they are 0 when they only hit once. That's when you have vertexes on the x-axis. That's both for h of x and j of x. H of x equals 0. J of x equals 0. That's what that means. Let's go. Number 2. Your friend, see, we've had surface questions. I forget what sections these were from. Maybe when we look at some of it, we can know. But I was like, we didn't do formulas together. I had to tell you what they were. Oh, they give you right here. Perfect. Your friend claims to be able to find the radius r of each figure given the surface area s. Do you support your friend's claim? Justify your answer. Find the radius r given surface area. Oh, these are 2 separate ones. Okay, well, I forget what section. I'm sorry. And by the way, this one, I believe, would have been out of section 4.5 if you're talking about discriminant. This one here, for the life of me, I can't remember. I want to say had to do with common factors or solving using square root. Maybe it was solving using square root. So I'm going to guess this is 4.3. Put a question mark. 4.3? Maybe? I don't remember when those formulas came into play. I really don't. They could have been chapter 1. Maybe they were chapter 1 when we used exponential properties. I don't know. Maybe 1.5? It seems like I haven't seen these kinds of questions in a long time, so I feel like chapter 1 might be it. All right. Part A. S equals 2 pi r squared plus 2 pi rh. This is the surface area formula for a cylinder. They're saying if you only know the surface area, can you find the radius of this figure? The answer to this one ends up being no. And the reason is because you also would need height somewhere. There's another variable. Now, that doesn't mean you can't get close. You absolutely could get close for this one here. But and I'm trying to decide if there's more that I want to say with that because, you know, we could play with completing the square and all that stuff. I can preach that stuff to you and see what we get. But the bottom line is there's an h in the way. No. H is another variable. Not unless you could somehow rewrite r in terms of h. If you find out the radius was twice the height or something like that, or unless they were given the height. So no. That's kind of it. Unless you want me to dive more into the whole when you get r by itself, I don't think I need to dive into that. That's not technically some. If it was, then it's completing the square, and then that's out of section 4.4, and that's not what this is. So I'm not going to go more into this. I'm sorry that I'm spending more time on this problem than I should be. S is 4 pi r squared. We totally can, and I'm going to for this one because I know completing the square needed. That's why I'm thinking it might be out of 1.5. You divide both sides by 4 pi. So first of all, yes. And how do I know? Because watch me do it. Divide both sides by 4 pi. You get r squared equals s over 4 pi. And then you take the square root of both sides here. Now, there's no plus or minus for these guys. R equals s over, you know what? I'm going to leave it like that. Square root of s over 4 pi. Bottom line is only one variable. Only one variable. And it's the one variable that we know. That we know. There's no extra variable such as height with that one. Again, there's no plus or minus with that. Oh, okay, number 3. Choose values for the constants h and k in the equation. X equals, this looks like conic section stuff. This would be section 4 point, before I move forward. This is section 4 point, I think 6. Wait, 3.6? Wait, conics were 3. 3 point, oh gosh. 3.6, focus of a parabola. Because it's an x equals y squared equation. Choose the values for the constant h and k so that each statement is true. Okay, so I have an equation. X equals 1/4 times y minus k quantity squared plus h. Now, just so you know, they're using this as your a value. I'm generally not a fan of that. I like to talk about a being 1 over 4p and all this kind of stuff, but it looks like the p value must be 1. So I'm curious what they want. The graph, okay, they're not really talking about focus and directrix. Oh, yeah, they are. Look at B and C. All right, well, let's see what we're going to do. The graph of blanketed blank is a parabola with its vertex in the second quadrant. Okay. Quadrant 2, we want a positive y and a negative x. So positive y, we just got to subtract a positive number, such as 3 is the vertex, right? And a negative x, we want, say, minus 4, whatever, something like that. These are open-ended. This graph would then look like at negative 4, comma 3, like that, and would be going in that direction there. Okay? Part B. These are very open-ended. Part B. The graph of this is a parabola with its focus in the first quadrant. Okay, now before I move forward on this, let's talk about this A. A is 1/4. Now the 1/4 is also A being 1 over 4p. Therefore, P is 1. P is the distance from the vertex to the focus and the vertex to the directrix. So for the focus to be in the first quadrant, focus in the first quadrant, it would be really nice to just have the vertex also be in the first quadrant. It's just got to be, it's going to be 1 to the right from there. If you want, I don't know, focus. So vertex quadrant 2, focus quadrant 1. How about that? Boom. That'll be x equals 1/4 times, you still need the y to be positive, so let's subtract like 5, something like that. And then let's make sure the x is also positive, so plus 2. Actually, you don't have to make sure of that. You could have it as 0 or something that's greater than -1, and you should still be fine, but I'm going to go ahead and do that one. Okay, part C. Parabola with its focus in the third quadrant. Focus quadrant 3. I think they could have done more with these questions than this, but that's okay. So third quadrant, you need to make sure y is negative. So now we got to subtract negative or add. Let's just put 7. And then x also has to be less than -1 with that focus p-value with the distance from vertex to directrix being 1. So let's put a -3 there, something like that. That should work out. Okay, interesting question. There's not much use. You could luck into being right and not know what you're doing just by putting points in quadrants like that. Excuse me, number 4. The graph of which inequality is shown. Well, it's a greater than or equal to. All these show -6 here. I could tell you, well, it's based on intercepts. So let me just copy this stuff over so I can write less. What I'm going to do is really talk about the intercepts. Well, let's also rule some things out. Okay, I'm going to rule out A and C because it has only greater than is not greater than or equal to. Those would have been dotted lines. I don't know why I'm yawning. This happened to me the last time I did a recording as well. It's not going to be those. So it's down to this or this. I believe it's supposed to be B. But let's take a look. This factors into x plus 3 times x minus 2. And this factors into x minus 2 times, minus 3 times x plus 2. Now the difference is in your x-intercepts. This has x-intercepts of -3 and 2. This has x-intercepts of 3 and -2. Now this is the one that has the x-intercepts of -3 and 2. So it looks like it's going to be B based on that. All these are greater thans, we shade above, all that kind of stuff. So that's what that would be. There's that page. One more page to go. 5 more problems. Number 5. Use the graphs of the functions to answer each question. Are there any, part A, are there any values of x greater than 0? Let me get this graph here. Are there any values of x greater than 0 where f of x is greater than h of x? So f of x is blue. It's the parabola. H of x is green. Now, I don't know if they're asking for the equations themselves. I think they're asking about concept. So I'm going to type some of these ones out here. Yes, there are x's greater than 0 that'll happen. Values to the right. Unlike my sniffles, I don't know if I can yawn enough to get rid of yawns. I would just have to rest. Yes, because parabolas continue increasing their rate of change, and it will surpass the linear function. So yes to the dress. Yes to the first one. Just gonna shrink it. Part A. Part B. Are there any values of x greater than 1 where g of x is greater than f of x? By the way, when they say f of x, g of x, stuff like that, they're talking about the y values. G of x is greater than f of x when x is greater than 1. Because, see, this is why they say 1 here, because they're equal here together. So if they're less than 1 also, something. Well, g of x, yes. An exponential function will also dominate a quadratic. So, yes here as well. Exponentials increase at an even greater rate than yes, because exponential functions ultimately increase at a greater rate than that of quadratic functions, of parabolas. All right. Excuse me. Part C. Are there any values of x greater than 0 where g of x is greater than h of x? Yes. So all these are yeses. So same thing with the exponential. It's going to take off more than the linear one as well. So this I could almost make the conclusion with you guys that if A and B are both true, then C has to be true. It's kind of like, if you're faster than me, and if this person's faster than you, then that person's faster than me, right? I'm not going to be faster than that person if I'm not faster than you, things like that. So yes, because exponential functions which already can increase at a greater rate over time than quadratic functions, will dominate a constant rate of change over said time. So yeah, I don't know if my explanation is great, but it's really C, A, and B. Because A and B are yes, C is going to have to be yes for that same reason. All right, number 6. It has 4 parts. Which state? Oh, it's not. Excuse me. It's not 4 parts. It's kind of a multiple choice, multiple selection. Which statement? Multiple choice. Which statement best describes the solutions to the system of equations? I don't know if I got to solve them first or what. Option A. The graphs intersect at the point -2, -8, so there's one solution. Option B, it intersects here, 2 solutions. Option C, no solution. D, the graph here has 2x intercepts, there are 2 solutions. Let me tell you what, it's not D. D, it might have 2x intercepts. That doesn't matter. We got to figure out where these 2 things intersect, so I can leave D out of it. Let's go ahead and solve for ourselves. Now, you don't have to do this. I could say you could do this. You could substitute -2, -8 into both of these equations and see if you get true statements. That means A is on the table. But that also means B is on the table. Now, listen, if A and B are on the table, that means C is out. If A is off the table, that means C is the only answer. So you could do that. I'm just going to go ahead and solve using a method, right? Let's go ahead and let's use the elimination method by subtracting. I get 0 is x squared minus 3x minus 6. Well, I'm looking at the possibility of not being factorable there. Oh, that's a +2. So let's do that. -10. Okay, that looks more factorable. -10. Okay. So if this is factorable, it's probably going to be B as the answer. So this factors into x plus 2 times x minus 5 equals 0, where x is -2 and x equals 5. Because of this already, you're seeing that it looks like it's going to be B. Let's plug -2 into the bottom equation. -10 plus 2 is -8. And plug 5 into that bottom equation. 25 plus 2 is 27. So you get -2, -8, and 5, 27. Because it's multiple choice, you go with a method. You go, girl. You go with a method that you so prefer. It looks like it's going to be B. You got to be careful, though, if you kind of do what I did to begin with, which says plug in -2, -8 to equations and see if they work. First of all, you got to plug it into both of them. And second of all, that's also a precursor for B. So you got to make sure you don't just say, it worked, so it's A. It could be B, and it was B. So you just got to make sure that that kind of works out in its favor. Oh, I didn't even circle that number 6 there. I'm sorry, but it was number 6. All right, we got 2 more to do. Number 7. Oh, 3 more to do. Excuse me. 3 more to do. Number 7. Which expressions are in simplest form? This is not obviously, but it's one where I'm going to copy and paste over. And I'll tell you what, if it's not in simplest form, guys, I'm going to simplify them for you. So, number 7. I don't think any of them are in simplest form. Let's find out which ones are in simplest form. Is that what they ask? Okay. No. I'll explain later why they are. Yes. Excuse me. I'll explain why these are not in simplest form later. No. Yes. No. Yes. No. I got a lot to redo. I'll call them A, B, C, D, E, F, G. Okay. A. It's not in simplest form because 45 is a perfect square factor of 9. You factor 9 out of there. The square root of 9 is 3. 5 remains inside. Boom. There's A. B. You have an irrational denominator. We must rationalize the denominator. I forgot to keep writing what sections these things were out of. I might have to go back and do that. So you get 16 root 5 all over 5. Now it's rationalized. This would probably be out of section 4.1. Just so you know. C. Cube root of 4/9, same thing, irrational denominator. It's okay to have an irrational numerator. You just saw that on the last one. Difference is this is not a square root, it's a cube root. So when it comes to me splitting these things up, the simplification process of rationalizing means I got to find something I can multiply and make a perfect cube instead. Square root of 4 is 2, square root of 9 is 3. That's great, but we need cube roots. If I multiply by cube root of 3 on top and bottom, I can get cube root of 27 on bottom, which is 3. And cube root of 4 times cube root of 3 is cube root of 12, which has no perfect cube factors in it, other than 1. 8 is the smallest one other than that, and that does not belong. So that's the simplified result. D, cube root of x to the 4th over 12, or over 2. Because there is a perfect cube inside of here, we can factor that thing out. Cube root of x cubed is x, and there's still another x that remains inside like that. Doesn't matter whether you think that looks simpler or not, it is more simplified. E, root 16 over 5. Square root of 16 is 4. 4/5. F, 2 times the cube root of x squared. Oh, that's simplified. Oh, wait, hold on a second. What was it before? Which are simplified, which are not? F is simplified. Pardon me. So that's no longer F. That one's fine. G is the new F. So we all good there. So F. So F, once again, irrational denominator. 3 times root 7 over root x. I'm going to write the 3 up top because that's kind of where it belongs. Multiply top and bottom by root x to rationalize this thing. You get 3 root 7x all over x, like that. Okay, so we are simplified. So these ones, the box ones were simplified. These ones were unsimplified, and I took care of it. Now, you weren't asked to do this. I'm showing you why they weren't and what you do to make them simplified. Before I keep moving forward, let's see what these ones would have been a part of. This, I didn't do this section yet, but I saw that this probably would have been a part of section 4 point, maybe 3. 3.7. 3.7 is what I was looking for. It's hard when I haven't done the sections before. These are those. This would have definitely been out of 4.8 systems. Did we do other ones before that? This would 4. Did I call the other one 4.8? This is 4.9, I think. Let's see. 3.7. Okay. 2 more. Number 8. You are making a tabletop with a tiled center. Copy and paste this thing over as well. And a uniform mosaic border. A beautiful mosaic border. Okay. Of course, they have multiple parts. Part A. Write the polynomial in standard form that represents the perimeter of the tabletop. Okay. So this whole length right here should be 12 plus that x plus that x. So I'm going to write 2x plus 12. This whole length here is going to be 2x plus 16 for the same reason. You got x's here plus that 16. So the perimeter is 2 of the 2x plus 12s plus 2 of the 2x plus 16s, which is 4x plus 24 plus 4x plus 32. Oh my gosh. Which is 8x plus 56. This is in inches. And there's your perimeter. Okay, sorry. I was making sure the tabletop was the whole thing because I was reading the question. So it looks like it is. All right. Part B. Write the polynomial in standard form that represents the area of the tabletop. Now we're going to be multiplying 2x plus 16 times 2x plus 12. This is kind of base times height. Not both 16s. One's a 12. So this is going to be you FOIL. So 4x squared plus 24x plus 32x plus 16 times 12. I don't know. I used to know that. So 192. So there's that. That's in square inches. Part C, the perimeter of the tabletop is less than 80 inches. And the area of the tabletop is at least 252 square inches. Select all the possible values of x. Oh, okay. So it needs to satisfy both things together by substituting them in. So 0.5 is out for the perimeter. Oh, is less than. Sorry, 0.5 is in for the perimeter. And 0.5... Oh, man, do I have to do this? Let's see. 2 times... I'm trying to think of the best way I want to go about doing this. Should I solve or something? 252. Does that have a solution thing with it? Okay, I'm going to do this. I'm going to do this algebraically. I'm not going to plug and chug. It's going to take forever. 8x plus 56 must be less than 80. Therefore, 8x must be less... Oh, this is a lot faster. 8x is less than 24, so x has to be less than 3. Therefore... 3, 3.5, and 4 are out. You can't have a perimeter that is 80 inches or more. So those are already out from that. Pretty cool. We can work that out. Now for this, 4x squared plus 56 plus plus 192 has to be at least 252, greater than or equal to 252. 4x squared plus 56x. I'm going to use if I divide by 4, I'm going to use like a completing the square version of this eventually. So I'm going to subtract the 192 over is greater than or equal to 60. I think if I subtract that over, and I can divide these by 4. So I get x squared plus 14x is greater than or equal to 15. Oh, you know what? This is factorable. Okay. Minus 15 is greater than or equal to 0. Okay, this factors into x plus 15 times x minus 1 greater than or equal to 0. Now, as far as what I want to do, this is all about critical points and stuff. I'm very well aware. This is partly section, say, when you multiply and stuff. It's partly 2.1. It's partly 2.2. But now that we've dealt with inequalities, it's also partly, I keep forgetting the sections, 3.7, I believe, for this number 8. Now for this here, what I want to do is find some critical points. The critical points are x equals negative 15 and x equals 1. This is where you would, I'm overdoing this part here, but, and honestly, negative 15 is something I care a little less about, but negative 15 and 1. To the left of negative 15, if I plug in numbers, I'm going to get positive numbers out. I'm just going to go and tell you that. Between negative 15 and positive 1, I get negative numbers, and then greater than 1, I'm going to get positive numbers here. So, in the end, you want to make sure that you have numbers that are either less than or equal to have positive numbers. You either need x's that are less than or equal to negative 15, which doesn't apply to us, or x is greater than or equal to 1. So this is going to be the result there. So I need x values greater than or equal to 1, which means I can't have 0.5. Okay, these are the ones that are allowed. These are the ones that are allowed. There you go. Okay. The last question, number 9. Let f of x equal 2x minus 5. Solve y equals f of x for x. Then find the input when the output is negative 4. This came out of the inverse section. This was section 1.3. We are not doing inverses, but we are applying an inverse concept. So y equals this 2x minus 5. And let's solve for x. We add 5 to both sides. Oh, sorry. The thing I talked about on that square root stuff, the ones with the surface area stuff, that might have been out of the inverse section. Anyway, we divide everything by 2 and you get x equals y plus 5 all over 2. So we solved for x. Then we find the input when the output's negative 4. So now we substitute negative 4 for y. Negative 4 plus 5 over 2 is 1/2. So the input is 1/2 when the output is negative 4. Another way of saying that is if I substituted 1/2 into this equation, I would have gotten negative 4 for y, as in f of 1/2 equals negative 4 as well. But we found it using another method there. Okay, guys. And that ought to do it for this one. This was the Chapter 4 Test and Cumulative Assessment. Cumulative Assessment wrapped up a bunch of other things in one, and I hope that that was very fun, enticing, informative for you. And I hope you picked up some good old wisdom and knowledge. So that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. Take care, and I will see you in the next one. Bye, guys.